Right, next what I'm going to show you on this 1 to 50 version, really basic version of the shelter, is how to do something called an exploded axonometric drawing. Explodeds are really good to show spatial relationship between elements of a building. For example, if you go to a museum and you're trying to find your way around it, usually they put up a plan or a map of the museum, and that shows all the floors and the circulation routes through the spaces. Also, an exploded axon is excellent to show structural elements to a design. So for example, here I'm going to use the exploded axo principle to actually draw in the columns or extract the columns as structural elements, also to project out the windows. And as the roof, we know that the roof would sort of like cover over our view, such as it in the case of the elevation oblique, that most of the drawing is not showing because of the overhang part of the roof. We're also going to project the roof up. The best thing to do, I mean, you can do the exploded parts right onto your drawing, but you should always check out for space, because you are going to move things up and to the side. Just make sure that what you are planning on doing will fit on your page. This is going to become a little bit clearer in a second. So let me just take my tracing paper down. So I'm going to overlay it with my existing drawing, and then I'm gonna start drafting this. It's also worth noting that if you decide to go with the tracing paper principle, it's really good, because if you mess it up, you haven't messed up the entire drawing, so you can just take it off and start again. It's also good to be able to just take parts out, so it's almost like a hand-drawn Photoshop version of your drawing. So you have different layers, and you can take some parts of the layers out and keep some parts in. So for example, you can do an axonometric drawing with the existing shelter plus adding your design, and your design could be on a separate layer as part of the exploded view. But then you might also decide to use the axo drawing just to show section cuts in your orthographic drawings in a scaled down version. So then you have that as a separate drawing, and you're not constantly messing with that. So I really strongly recommend that if you're doing an exploded axo, do the exploded parts on a separate sheet of paper. So what we are doing next is we are going to refer back to this principle of the 45-degree rotation. So the original columns would be sitting here, but what I'm doing, I am going to slide them sideways out of the shelters in a 45-degree. So I'm going to draw a parallel line with my imagined ground line through all the 3 columns, like this. And the column was there originally. And I am just going to decide how far do I want to project out the columns. So we are sliding it out this way. The column would be sitting in this direction, in the Z direction, and it's still going to sit in the Z direction, but we want it to be slightly out of the shelter. So I'm going to say, I don't know, I'm not measuring this, but I want the columns to be projected out about this much. So my first column is going to sit here in this point, and equal distance from the second. And same applies to the third one. And then I am just going to draw the plan view of the column here. And then in a second I am just going to project up their height into here. So I really quickly projected up the columns, but I don't yet know their heights. And if I decided not to scale up and down based on my measurement sheet, then also what I could do with my compass is actually just take this height, because this is also the height of the columns, yeah, and I just go in the center point and I just measure it up or the bottom point, like that. And then I just got to finish them. Please remember that any circles in a plan oblique still stays a circle, so you don't really have to do anything with that. It's not like in the elevation oblique where any circles just become ellipses. So circles stay circles. So you guys could see that this is what the columns look like when they're sort of pulled out, projected out of the shelters. What you can then do, that this sort of working outline here, the projection line, you can use a rubber, or you can just redo it really neatly, and you can dot it in, so you can make it as a dotted line, the construction or projection line. Obviously, if you meant to do it like that, or like I'm rubbing it out, you get a much better results. So forth. So next I'm going to do the roof. I am going to take the roof and I'm going to project the roof up so that the roof is not going to cover up the majority of my drawing. So in a normal scenario where I would draw the roof right on the top of the walls of the shelter, what I would do, as we are dealing with a curved structure, I would start by enclosing it into rectangle. So the edges of these rectangles are still visible from my plan, and then in the z-axis direction I would project up to the height of the vertical walls, to the connection or the meeting point where the walls meet the roof, and then I would start drawing it in here. But as we said, that would completely cover over the existing shelters. So what I started to do here, and you could see my markings, I started to go up literally in this direction so I can start pulling up the roof, and then I started to also measure that how high do I need to go if this is the width of the roof. So if I double the height, so I'm pulling up twice as high, then the roof would still be covering my shelter. Then I went up 3 times the wall height. It doesn't matter, this distance could be anything, it was just an experiment on my behalf. And I started to see that if I pull it up quite high, if this corner is actually pulled up that way, then it will definitely not cover up any part of my shelter. You can also do it in 2 ways. You can pull it up and put it to the sideways at the same time, but I just didn't have the time to redraw, so I was trying to save my time. But you're gonna see that it works really well like this too. So I'm just translating this rectangle, which is enclosing the semicircle here, up here, where I pulled it up. So I find the 2 corners. Next I am going to find the center point. Again, you can halve it properly, or you could just be very lazy and just say to yourself, I do it like that. Next I'm going to find the center point of the circle. It should be here somewhere. So it sits on this line. It is there. Then I am just going to measure it out. And it should roughly work. And next I need to find the straight parts of the shelter. Because I had been coming up so high and offsetting the roof in 45 degrees, it doesn't look like I can completely finish it off. But as far as I can go, I am going to project it, and I'm going to show you how to finish it. Next, what we'd like to see to find this point here is that we are just going to project that upwards. So if I had just drawn a line through there, could do the same with this line here. It is there. They should really be sitting on my y-axis, the same point where my center point is, and then I can just draw a parallel line with my center point there through these points. And next what we would work out is the thickness of the roof. So we know that the roof is 100 mil. So we are going to project down 100 mil, repeat the semicircle, and then extend the thickness towards the back. And there you have it, there is a projected up roof for the shelters. You would do exactly the same on the back, but as you could see it wouldn't quite fit on the paper. It's not so much because I had budgeted my paper wrong, it's mainly because I can't fit such a size drawing into my screen. And if I downscale to 1:100, that would be so tiny that it would be very difficult to draw. So next I'm going to project out the window, this curved window here, and you guys could have a look at that. So as this is still the curved wall, it's very much the same game, that I got to take this shape and sort of pull it out this direction. So we're going to still look for the rectangle to encase our semicircle. So I'm just going to find the ends of that. And then I am going to project up the height of it, and then I'm going to use my compass to draw the curve. So what I had done here is, this is the structural opening, and the window frame is supposed to sit right in the middle of it. So then I divided the wall thickness, I halved that, and that line I just projected along the x-axis out. I had done the same with the other corner. Then I halved this distance so I could find the center point here. And next what I'm going to do, because I think the middle one is slightly out, I'm just going to look for my radius. So then taking from this point, I am going to establish where my window frame will sit on the bottom, and then I am going to also draw it up in the height of the windows and draw in the window panes. So what I had done here, in the meantime, I reconstructed the window frame. This is the height of it. I also divided it into 4 parts, because in one of the shelters there are 4 parts to the window. Next I need to divide this distance into 4, and then again repeat these circles to draw in the window panes and the window frames. So this is what the final one looks like. So you have a lot of different details on a piece of tracing paper. You can kind of double check yourself that have you drawn the heights correctly, is everything else fitting, for example my roof, can I overlay it, is it accurate, or in case of my windows I can fit my window panes into the shelter. But you can also just remember your projection lines and pull them out from their places. In architecture, these construction lines, linking it back to their places, we always keep. So please keep those and use dotted lines to refer back to them.